Assignment. I submit orders, show live market data and trends, walk through the core machine logics, and explain the design choice inspired by regulation, national market system, price time priority, and the internal order protection. So first we start with my code. So I made the front end from React, and the backend is from Python Django. So here we start. So first of all, I start the server of front end and the backend server simultaneously. So as can you see, the market web server, the market data web server show red, and the trend show red because earlier it was not activated. So when I activate the Django server, it will just start now. It takes some time. Uh, okay, looks good. So as you can see, the server gets started. So first I see the book. So in this postman, yes. So in this postman, I will place an order for a limit, and I will sell the quantity of 1.5 for 65 100. The price. If I send it, yes. So the order ID is been created. It is an unique ID that every order should have. And as you can see, in our top line depth, the best offer that the market has offered is 65 100. The price is that, and the quantity is also that. Now I will change quantity to 1 and price to 6500 65,000. Now if I send it, another new unique ID has been created, and as you can see, the best price is on the top of the chart. Best offer is on top of the chart, and after that I will place the order for buy, and I will buy 2 units quantity, and the best price that I can pay for it is this amount, 64,900. If I send it, as you can see, another new ID, and now you got the best bid price, which is 64,900 that I have give this through the API. And also, if I want to check that my border is working or not, I have make a endpoint called snapshot. If I send it, I can get the timestamp what I have done. So the best bid is 65,900, and the best offer that the market has is 65,000. And this is the ask that we have been done. That I am asking for one unit about 65,000 and 1.5 unit for 65,100. And bids there is I bid for 2 unit for 64,900. So now, 1 second. Hmm. If I want to buy from market, about the quantity, no, sorry, for that, okay, I want to sell zero point 0.7 unit quantity for exact the same price as 65,000. So what will happen that if I want to sell it, it will generate a new ID, and as you can see from this, the quantity has been add on. It is not like that the price has been the price has been actually add on. It have a FIFO queue. So the first price that I have been mentioned, that it will be one quantity of one will firstly consume, then then 0.7. the total quantity is shown as for simplicity for this particular price. So now if I hit this, once again, so now if I want to buy from the market and I want a quantity of one, okay, so I want to buy from market side of quantity of one, and I will send it. The order ID has been updated, and as you can see, the first time I bid one, so the one has been consumed first, and now the remaining is 0.7. So this is the so this is the logic that I have been worked. So according to the FIFO, the first in first out, the first has been consumed, and now the remaining is this. To confirm this, we can also again try this. Now you can see that the now you can see the remaining the remaining quantity has been updated, and also the price of that. Okay, at the same price of 65,000, we have two orders now. The earlier one fill first. The market buy hits the older 65,000 first. That's price time priority. Better price first within our price FIFO. Now, if I again do this, actually, if I again buy two quantities, for example, a market buy first consume the best price 65,000 before moves to 65,100. As you can see, I have consumed the all 65 1000, and the I have consumed some of 0.2 of the 65 100. So as you so it cannot skip the better price. Here you will see the first at 65,000 remaining 0.7, then continuing 65 100 for the rest. Now for IOC and fork behavior, I will demonstrate the IOC and fork behavior. First I will say IOC. We will buy quantity, let's say 3, and the price we have to pay is 65 100. Okay, looks good. Yes, as you can see, if I send this, all the IOC immediate or cancel, it fills whatever is available right now at 65 less than 65 100 and cancels the remainder. It never rests on the book. Now for fork, for fill or kill, it must fill the entire 3 instantly at better than 100, or it cancel completely, no partials. If I say quantity 3 and 65 100, now as you can see, we don't have any amount remaining, any quantity remaining, so it will not work. It will not showing any data. So the main idea is that I have shown the all the functionality that has been mentioned in the assignment. So for the code, so the my code logic is here. So in my engines.py, I will show you. Yes. So my engines.py. So there is a there. So there is a price level which will show you the best price that is present in the market, and there is also a side book. So there is a prices and levels. Here's the order book. So order book has two options. There is bid true or false. If it bid is true, so bid will be from higher to lower, because so the priority, so it will show you in the ascending order from higher to lower, And for ask, it will show you the lower to higher in descending order, in ascending order, sorry. One second. Hmm. So this is the main matching logic. So whenever a user is from the side and he used to buy, so I will show them a reverse book of ask. So if so the user can see the best price for buying, and if it is used for in sell, so I will show them the reverse book of bids. So the best bids, so he can bid a best bid for that. Basically, the idea is it will show the lowest price, it will show the highest price to the user according to their choices of buy and asks. Order types. So the my design choices and regulation national market. So RGMS, price time priority, shorted price, FIFO-Q implement price time drastically. Internal order protection, a marketable order must consume the best available internal before asking for accessing works level. We never trade through best price. Why I choose Django plus DRF plus channels. Fast scaffolding, it has object relation mapping, admin and migration, clean JSON validation, built-in WebSocket via channels, perfect for compact assignments, and fast API would do also work. Here I optimize the delivery speed plus clarity. And for the memory book, I choose SQLite trade, speed where matter matching, durability for audit trades, and with the general snapshots. For the performance analysis and optimization, I use and markets. I batch 10,000 limit order, then 5 market order locally on 3 Python 310. So to recap, the engine enforces price time priority and the internal order protection stream PBO LQ, best bidding order, and the trade in real time. And the persistent trade for audit. I show the market limit IOC and fork behavior end to end and walk through the core machine loops and data structure. Happy to discuss the extension like stop order, free model, snapshot generals, and performance trading by Samba. Thank you.